Okay, so this video is going to help us go over partial sums for arithmetic sequences. So now we're talking about the series portion, not just sequence finding our formula or a future term, but we're actually going to be finding the sum here of the first n terms of an arithmetic series. So I can tell from the notation that we're talking about a sum here because of the capital S. These two formulas do the exact same thing. So let's look at them for just a second. The first one here says that I need the first term and the nth term, and then I'm going to add them together, and then I'm going to divide them by 2. So I'm going to focus on that part alone. If I said you add two numbers and divide by 2, you're finding the average of the terms of this sequence, and then you're multiplying that average in number of times. So basically it's saying if you can, instead of just adding them all up, if we can find the middle, so think about two terms that are very far apart, if we found their middle and multiplied that out, that's going to help us get to the sum faster. Now the second formula does the exact same thing, but instead of a sub n, it actually puts the explicit formula. So it does the first term a sub 1, and then it includes that we're adding instead of a sub n, but it puts this in the formula. So now there are two a sub 1s plus the common difference times n minus 1. So you might say, why would I want to use this one? It's so much longer and more complicated looking. But this one, you don't have to know the future term. Right? You don't have to know a sub n. So it'll kind of depend on what the problem gives us as to which one we're going to use. You also need a calculator for this part of the notes because we're going to be verifying our answer with the calculator and practicing typing our summation. So, all right, back to the notes. This is number 6 on the tiny notes. It says if we are given the sequence 0.5, 0.9, 1.3, and 1.4, find the sum of the first 10 terms. So find S sub 10, the sum of the first 10. So I'm going to actually do, let's go ahead and say I want to do the long version here. So instead of, this is going to mean I don't have to find what the 10th term is. I can just go ahead and say, okay, I know that n here is 10, so 10 over 2, times, and then it's 2 of the first term, so 2 times 0.5, plus, I can clearly see the common difference is 0.4, times n minus 1. So here, that's going to be 10 minus 1. And then we can go ahead and work this out. So that's going to be a 5 times 1 plus, and this is 0.4 times 9. So 4 times 9 is 36. So this is going to be 3.6. And so the sum of the first 10 is 5 times 4.6. And then we could work that out, or you can go to your calculator. Or we could do it, right? Because 5 times 4 is 20. And then 5 times 0.6 would be like 3, like 30. 30 would be the decimal over 1, so it should be 23. You can double check me, or we could work it out, the long version. Okay, so the sum here is 23. Now, if you wanted to do the short version instead, the short formula, then you would first have to figure out what a sub 10 is, what the 10th term is. So you would have to do 0.5 plus the common difference, so this is just the explicit formula from our last video, times 10 minus 1, so it would be 0.5 plus 3.6, because we worked that out before, so the 10th term is 4.1, and then you could go to the short formula, where you have your first term, So n over 2 would be 10 over 2 still. First term is 0.5 plus the 10th term is 4.1. And so it ends up being the exact same math of 5 times 4.6 or 23. Okay, so two different formulas. I don't know why I wrote them on this side, but the left one is using our long form, and the right one is working out with the short form. Okay, so now let's go into actually working with summations. So you need to use a sum here because it asked for the sum. So another way you're going to know it's asking for the sum is if it uses a sigma notation for our summation. So it says find the partial sum of our lower bound is 10, our upper bound is 100, and then the expression is 6n. Okay, so let's decide. I think it's going to be pretty easy to figure out our first and our nth term here. So I'm going to go ahead and use the short form that requires my first and my last term. So let's see. Our first term would be 6 times 10, or 60. Our nth term from our upper bound would be 6 times 100, so 600. And now here's the tricky part with the summation. With like the sigma notation. So when I go to find this partial sum, when you're thinking about what is n, I know 100 minus 10 is 90, but really this is 95 total, or not 95, 91 total terms. Because think about just if you were counting from 10, it would go 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 10 terms away only got me to 19. So I would go ahead and say this isn't just 90 here, this is 91 over 2, and then I'm saying it's the first term we found was 60, and then the last term, 600, and then we're going to go ahead and work that out. Also, I don't know why, but that was like a super weird way for me to count to 10 with my fingers. Like, why would I start with my pinky? I don't know. Just had to acknowledge that. Okay, so this is something that we would definitely be on the calculator part. So we would have alpha y equals, I'm going to make a stacked fraction, 91 halves times 660. Oh yeah, so our partial sum is 30,030. I guess I should have specified over here in this problem was 91. And now we're going to practice typing this on our calculator. Okay, so remember that to get to the sigma notation, it is alpha window, and then the second option. And then we're using x instead of n, so the lower bound is 10, the upper bound 100, and then to the side, my expression is 6x instead of n. Hey, we did it right. So if I put these on the non-calculator part of the test, they will be easier numbers for you to evaluate. Okay, then let's go ahead and do another one. 8 says, find the partial sum of my lower bound is 1, my upper bound is 20, and I'm evaluating 2n plus 5. So same thing here, I'm going to find the first term. So I'm going to plug in a 1, 2 times 1 plus 5, 7. I'm going to find the 20th, or the nth, because we're going to talk about n in a second. The nth term here is 20, so 2 times 20 plus 5, so 45. And then be careful here, n, remember, is not just 19, it is 20. I'm going to go ahead and use the short form again, right, since we just found the first and the nth terms. So n over 2, 20 over 2 times the first term of 7 plus the nth term of 45. This one would be a non-calculator type question because we can divide that, and it's going to be 10 times 52. So 520, and then we'll go ahead and verify that with our calculator. So we'll get rid of that old one, and alpha window, number 2, we're using x instead of n. Let's see, my lower bound was 1, my upper bound is 20, and 2x plus 5. Hey, 520, we're on a roll. Okay, last one is our final word problem. All right. So keep in mind it's probably going to have a partial sum or at least related to sequences. Probably an arithmetic pattern that we're expecting here. So it says, a city bowling league is holding a tournament in which the top 12 bowlers with the highest 3 game totals are awarded cash prizes. First place wins $1,200, second place will win $1,100, third place will win $1,000, and so on. List the sequence for this problem. Okay, we can do that. So listing the sequence means we're listing the collection of values, of terms. So 1,200, 1,100, 1,000, it's going to keep going, 900, so on and so forth, and then the last number is just going to be 100. Think about, we wouldn't want to list 0, because if you don't win any money, you're not part of the 12 winners, and then of course we don't want to list negative. Okay, so B says, write a sequence A sub n. And we can do that. Sounds like an explicit formula to me, so I'm going to go ahead and just list that formula again in case you forgot. And it says, N is the place in which the bowler finishes. So first place, let's make sure this makes sense, first place gets the most money, and 12th place would get the least amount of money. So then my formula would be my first term, or the biggest winner, gets 1,200, and this is our first common difference that's negative. So the common difference is negative 100, so we'll be subtracting 100 times n minus 1, which I am going to clean up that formula, and I expect you to do so as well. So 1,200 minus 100n plus 100. And so you could either write it with your constant value or your n value first. I'm going to put negative 100n plus 1,300. But again, either way would be fine. So I think we answered B. And C says, find the total amount of prize money awarded at the tournament. Ooh, that sounds like a sum. Practice solving with and without the calculator. Okay, so I'm going to go, let's see, total would be our sum. I'm going to go short form since we know the first and the last value here. So think about, we're adding together these 12 items in our sequence for the 12 winners. So N is going to be 12. First prize was 1,200. And then the 12th prize is 100. So 6 times 1,300, which we then can multiply and get $7,800 in prize money. So if we are going to turn this into a summation, if we start with n equals 1 as our lower bound, be careful. We want to include 12 winners, so I have to make sure that this is going to go all the way to 13. Oh, no, it's not going to go all the way to 13. Hang on. We didn't need to do it that way. We only have 12 here. It would be if we were given the summation first, that we would need a different value. So here, we're going to have negative 100 in plus 1300. Yes, because this is our first winner up to our 12th winner. So alpha, window, and our summation. Oops, went too far. And that gives us the exact same value as well. Right, so this, sorry for that miscommunication a minute ago, but 12 minus 1 is 11, but this still includes all 12 of our top finishers. Okay, so now it's time for you to practice with your DP. Make sure you get one attempt at least finished today. If you weren't able to get a high enough score on the first or the second DPs for this week, then go back and do that now. And we will keep going with geometric sequences next week. So all of our patterns will be multiplying instead of adding or subtracting. And of course, I'll be able to answer any questions that you have when I get back. All right, y'all have a great weekend.